My name is Martin. I'm the head of creative specialist at the Foundry. And today I would like to show you what we've been cooking across Katana 9, Nuke 17, and then a little sneak peek into a new addition to our toolset that is highly focused on AI workflows called Griptape. So let's start with Katana. Essentially, Katana is now really closing the gaps within their USD implementation, and a lot of the under-the-hood work will allow you to accelerate and essentially pipe the data sets that are based on the USD as a backbone throughout all the applications. So to accelerate the workflow, the lighting and look dev workflow inside of Katana, we added a native USD lighting, USD native material workflows. We have a Hydra 2.0 rendering, and inside of the application it actually manifests itself through a tool that we affectionately call USD super layer. So for those who are familiar with USD, every time you perform any side of operation, the stage needs to be rebuilt. This tool allows you to encapsulate the workflows into one unified framework where the data can flow through the application, and you will get the least amount of performance hits as you operate on any properties across many multiple features across the whole application. This preserves efficiency and allows you to essentially build on one stable foundation across the whole tool. It can be customized to your studio needs, and essentially it allows you to have one standardized workflow across materials, generating of primitives, modifying properties, modifying attributes, and essentially building the workflow through USD way more efficiently. So just a small example here, I have generated 1,000 lights essentially with one click. On top of this, for those of you who are familiar with Gaffer or the previous workflows inside of Katana, Gaffer is the native lighting toolset inside of Katana. Now Gaffer is fully USD compliant. It generates USD lights. It creates USD materials and allows you to not to leave the USD pipeline within the application. Materials, in a very similar fashion, can be then dragged and populated within the USD layer, so you can really drag in any property from anywhere within the stage, address it, change it, override it, and then push it back as a separate layer, or just continue lighting, continue modifying the data as it's flowing through the whole pipeline. And all of this could potentially result in a workflow that we are quite excited about. Hydra 2.0 plugs into many applications potentially, and really we are on top of this, so Katana can live within Hydra and then serve its data to plethora of renderers. So essentially any rendering engine out there that is compliant with USD can ingest this data, display it, process it, and then use it. This is just a small list of the ones that could do it, including any in-house renderers that can work with USD could be used within this framework. So now I'm going to poke the tiger, the proverbial tiger a little bit, and I'm actually going to run Nuke 17 live, just so you can get the taste of the actual performance, how that operates. Now keep in mind that this is a tiny little laptop, but it performs actually quite well. So on the backbone of the USD implementation, the similar team also propagates through Nuke, and we are trying to enable the new and exciting workflows and technologies within the application. Nuke now features Hydra viewport, so we can run much higher data count. So one of those technologies that I was kind of hinting on is the inclusion of Gaussian Splats. I think they make a lot of sense within the compositing context, where you can run really photorealistic assets through the whole application, modify them, change them to whatever is needed to make the backgrounds, for example, match with the foreground. And so to show you how that actually can operate, I will just jump into one of the Nuke comps here. Just open up, oops. Yeah, the monitor switch didn't help, so let me quickly fire Nuke again. And we can have a look at the Splat integration. Okay, so Victor, who will follow me after my session, will show you how we can generate Splats and create these amazing assets. we can ingest them and consume them inside of Nuke. So to show you how a splat could look like, I will just load it in directly into the application, into the viewport. There are several million points inside of the space that describe how the 3D assets should look and how it should perform. So if you look at this particular scene, I can start rotating around it, and you can kind of start resolving what is actually coming in and what might be the fidelity of this asset. Now, this now lives within Nuke as a native USD data, and even though it was ingested as a splat, to start fixing it and operating on it, I can already start using the new updated 3D system that is entirely based on USD, and if I just click on that, the asset will flip, and now it makes more sense. So what I really did is I transformed all the points upside down to allow you to look at this. So if you look at the splat, the fidelity of these can be quite high. I can get really close. It's all 3D. You can start essentially dissecting it and reusing and repurposing elements from this. The main difference between splats and, let's say, photogrammetry or 3D scans is the fact that not only you will preserve the texture sets and the textures and how the points look and the colors, but also it will preserve things like hints on reflections, as you can see how the specularity is changing on the window, and I'll get some notion of what's happening in the building. So this really lends itself nicely to, let's say, matte paintings and assetizing of photographs and building up environments. So let's pretend that this is a part of a shot that I need to recreate. I can look at the scene from a point of view that I would like to use within the shot, and let's pretend that the director has a sort of a suggestion where we need to add some element in the foreground. For that, we introduced a field shapes that allow you to define an area on which Nuke will operate. These are fundamentally a volumetric shapes that define a certain area of the points where I would like to do some sort of operation. I can invert this whole section. Each of these field shapes have predefined shape, so you can combine and create really sophisticated areas of influence. If I look at the geo-delete, then I can delete the whole environment, and effectively I created an asset that can be then reused, repurposed from shot to shot, and change how the whole thing behaves. If I look at the geo-transform, I will need to also create a shadow for the table. And since the splats are fundamentally points, they kind of live in the space between pixels and 3D and their points. So I can create another field shape here, blur it a little bit, and then add a grade underneath to fundamentally change how those points really look. So I'm gaining them down, and when I merge it back with the surrounding geometry, I'll end up with my table now recreated and moved to another location, effectively creating a completely new and adjusted environment. All of this then can enter the USD stream because Nuke allows you to save splats into USD, USDA, USDC. But you can also go back to PLI or ABC again quite easily. From here, I can bring the asset back again into Nuke, render it, add a traditional 3D object into the space, like this simple card, and merge it all back. So now I'm combining really the splats with splat rendering with a traditional 2D rendering inside of Nuke, and I can start adjusting properties like Z depth or defocus and start compositing. So this is quite flexible and fairly easy to produce, and I think the amount of time to essentially generate a photogrammetry-like environment could be substantially reduced. Just to give you another example from a slightly different bucket, where I have a different environment. This one was created just by using a single image. Unlike the previous environment, I have a scene that was originally a single picture, and it was extended to generate some depth information. So now I can move around the environment more effectively. On this side, I'm using a regular 3D asset. This is just a simple model. And perhaps the more interesting aspect of this particular setup is that I'm using deep data to merge these elements together. So when they do merge together, the new replacement castle will integrate with the splat rendering seamlessly, and I'll get the element actually rendered behind the trees, as you would expect, because they really occupy the same 3D space. It's much easier to adjust and work with. So to quickly illustrate another aspect of splats, we can also deform splats and operate on them and create additional effects, sort of like a particle-driven effect, where here we have a splat of the actual creator of splat, or Mark, who was leading the team who allowed you to, who integrated splats into Nuke. And then I can create additional field nodes that will create, for example, noise, add curves, warp, and then any splat can be also deformed and adjusted that way. Just close all of this. So you can see that now these particle points are deformed. Poor Mark, but hopefully it illustrates how this can be procedurally adjusted. Let's say you need to create waves or hills or adjust the splats in a more artistic way. Nuke allows for that. And just to give you a preview of how like a high resolution, high quality environment can be captured from multiple pictures, this would be a good example of something that could be captured on a set just by walking around or shooting a video, shooting multiple pictures, and then you can end up with a very accurate 3D representation of any environment that can really behave like a CG plate on steroids. I can really look at it from any camera point of view and use it that way. The 3D work inside of Nuke also continues. We have added, well, in the new 3D system, we allowed for ray tracing, refractions, and reflections. So to illustrate this really quickly, here I have a card that has this ship element on it. If you look at the 3D card here, this is a regular 2D card inside of Nuke. And on this side, I'm bringing a USD asset, which has a bottle. And I guess you know where I'm heading with this. By combining these two elements, I want to create a ship in a bottle type of effect, where the bottle will refract through the bottle, but inside of Nuke, without going into a 3D application, rendering the refractions, and then bringing it back again. I can simply assign a reflective shader that also allows you to render refractions. And when I do allow Nuke to render this, you will see that now the bottle is inside of the ship is inside of the bottle, and it's curved properly by the curvature of the glass surface. This just reduces the friction and the number of iterations that you need to go through between the 3D applications, the 2D applications, and certain effects simply makes more sense inside of Nuke or inside of the 2D environment or 3D, 2D environment rather than inside of a full-on 3D environment. On the performance side of things, we have updated the TVI scale and number of nodes that are now capable of GPU acceleration. To illustrate the speed improvements, let's just connect. This is the older TVI scale. Let's clear the cache. And I will actually artificially increase the resolution on this so you can get to appreciate how fast this can be. Let's just create a reformat here and take the image into my TVI scale. So now I'm effectively going from 4K footage to 8K footage. This is the old node. The new one is GPU accelerated, so actually we'll disable the scanline optimization. So it takes about 20-30 seconds for this one to resolve, but it's a substantial jump in the resolution while it's preserving most of the details in the picture. And it's a really viable alternative to AI upscaling in terms of performance. So here we will if I actually did connect this. Let's go from this one here and this one here. And now we will get to see how it actually performs. So since it cached, it was pretty quick. But now, if I actually connect the new one, you'll get a performance under a second, really. So if I do the same thing for the new one, I'm going from that's how long it took really to generate this. And you can essentially stack these on top of each other. I can go easily to 8K and just keep on duplicating, and the performance is quite excellent. It's a fairly common workflow to render at 2K, go to 4K for the final delivery, and we can help there. The deep performance was also enhanced inside of Nuke. It's about 50% faster, so any operations that you might be doing with the deep data inside of Nuke can benefit from that, and that applies to deep reading, deep writing, and any kind of operations. In this case, I'm doing just a simple color correction, but if I disable these nodes right here, you'll see that even on this little laptop, it actually calculates this picture at 2K quite speedy. OFX plugins, for those who are using OFX plugin, this is a welcome addition. So now we lifted the cap from, I believe, 4K, and you can essentially use any OFX plugin, including the internal plugins inside of Nuke, and go above the previously capped resolution. On the pipeline side of things, and machine learning things inside of Nuke directly, our toolset that we called Copycat in the previous releases received a bigger sister called BigCat. And the main difference in the BigCat workflow is that not only you can use much larger data sets. So for example, in this case, we were using 28,000 images to train for a given effect. This effect was to remove motion blur from any arbitrary footage if you need to, but it can be really anything. This is one of the main advantages of Copycat and BigCat versus the pre-trained models online, where you can use this to train on your own data. So just like Copycat, I have two inputs. One is motion blurred, the other one is not. And then I'm feeding this to BigCat as an input and a ground truth. Ground truth is the desired outcome. Input is the motion blurred one. And unlike Copycat, you can also introduce a validation set that will essentially define the area which you consider to be valid, or that describes the problem well. So as BigCat is training and tries to generate the effect that you're after, it will validate and check whether it's doing the right thing throughout the whole process. This particular setup would go through 1,000 epochs. Often it needs to be higher, but throughout every iteration, it will make sure that it's trying to arrive to the right outcome. On the pipeline side, we introduced a new set of tools to Nuke in Nuke 16 that we call multi-shot or graph scope variables that allow you to drive multiple shots and multiple setups, multiple mutations of a comp from within one setup. And Nuke 17, we kind of closed the loop by adding extremely capable functionality that allow you to call any Python script on variable change, whether the variable is added or any operations that you need to do. So the way it really manifests itself inside of Nuke is that if I change a variable from, let's say, work in progress to published, it's calling my own personal script automatically. This is not built-in feature, but you can really hook it up to any Python operation. In this one, I'm submitting it to ShotGrid, then I'm submitting to Deadline for rendering. So you can cascade and stack all of these operations, whatever your pipeline really needs to be doing. So, and within the timeline tools, we also added our enhance. This was really requested by quite a few people, and by popular demand, we updated the annotations to actually not only enhance the artistic experience, but giving you a way to communicate around a given change or adjustment directly. So not only can do like dodge and burn and change visually what needs to be done to the shot, but also there is a whole sort of chat system that allows you to talk about the feature, leave comments, and then push it to Asset Manager, download it back, and really have like a unified system around the changes that are coming in for every shot, every clip, and so on. So this kind of encapsulates Nuke 17, what we've been doing on that front. And in the AI space, we recently acquired a tool or framework called Griptape. Oops, not from the beginning. Let's go back to Griptape from current slide. So Griptape Nodes is a AI orchestrator that allows you to connect and create workflows around the established models that are available online. The models that you might have been using, how many of you have played with something like Foundry UI? Okay, I'm talking to you now. Wonderful. So, but fundamentally, Foundry UI, just like in a similar fashion to Griptape Nodes, allows you to connect multiple AI models into one workflow. Griptape, right off the box, allows you to do it much more effectively. Foundry UI can be very granular. Griptape already encapsulates the workflow and makes it much more accessible for artists to be used, to learn it, to actually explore what AI can potentially do for you. It consists of three sort of layers of tools that communicate together. First, you have the Griptape node editor. That is the UI that is user-facing. That's where you develop these workflows. Then we have a Griptape engine that can run on a server or on your local machine. It can run in the cloud. It can run on premises or locally within your facility. It's both on-prem and off-prem, depending how you need to set it up. And then underneath it all are the models, right? The models that actually do the work. So we don't do the models, we control the models. The UI looks somewhat like this, where it's essentially a familiar node-based operation where you connect multiple operations together to get some sort of output. So in a very simplistic way, you can start building agentic workflows that the agents will be doing a specific task, connected together, and then drive the development through step by step. To illustrate how simple this can be, I just added some sort of footage that I need to, let's say, generate masks from. I can connect it to a SAM model. This particular node is already pre-built and comes as a part of a Griptape libraries. There is no additional nodes to be created, no properties to be figured out. You can be granular as you need to be, but if you don't need to be, then you can just use it simply out of the box as it is. And then I can export this. Well, I will tell it to make mask for a head. This is heavily reliant on what the model can do. In this case, I'm using SAM3 to generate the mask. It cooked a little bit for some time on a workstation that was connected to this laptop. And then I'll get two outputs. It's the composite, which you see in front of you, the blue head. And then also it can generate just the black and white image that can be used as a mask in another application like Nuke, or really any other application. So when I do export this out, then I can bring it to Nuke and use it to grade, for example, this particular element. This is one of the most simple workflows you can do. You just have the footage and then a model that can do something. I think it will become more interesting when you start chaining these workflows together. Here I'm doing a very similar setup in a sense. I'm using SAM to generate the mask for this car. This is SAM3 again. These days it is one of the better segmentation models. This space keeps on developing rapidly. Griptape is on top of it. We are constantly connecting new models and making the work, or making Griptape capable of communicating with other AI models, AI diffusion models specifically. And here I'm connecting the output from SAM3 to another model called Minimax Remover. And Minimax Remover will then do its magic and output the desired outcome. So essentially, based on the mask, it will fill in the gaps, remove the car, create something that could be considered a clean plate, and I can replace the element or the car with another car, spaceship, whatever it might be doing in the shot. And this whole idea of building up more and more complex workflows through Griptape really kind of extends nearly infinitely. In this case, this would be like an exploration example to figure out what we will be actually doing, what kind of animals we should be placing on this footage. The footage is real, animal is not. And this was essentially prompted through multiple models. I believe the CDance was used for this. The general issue with AI models is that they cannot just give you the element, at least at the time when we were doing it. They couldn't give you just the animal itself. So we then had to use, again, SAM to create a mask for that animal that was merged with the footage. The interesting bit, I think, for us in the VFX realm is that not only it can create the animal itself, but it can also generate things like ZDEP passes, normal passes, and passes that can actually enhance the compositing and can do relighting and other operations. So this is all nice and fancy, but if you look at the complexity of the graph, you can see that now I'm actually doing something really complex. I'm passing the data from one model to another, building up a workflow all the way up to the complete shot or not complete shot, to get the elements so I can actually complete the shot in a compositing application. And Griptape also allows you to string and generate the prompts procedurally. So in this case, this is the development sheet or workflow for the giraffe, where I'm in this side telling it, give me a giraffe. It will make a giraffe, then I'm adjusting the giraffe. This is all done procedurally based on merging and procedurally combining multiple levels of prompts and refining the prompt to fine-tune what I'm actually working for. And on this end comes out a contact sheet for the character sheet for the giraffe. If I tell it to do a lion, procedurally it will run the whole process all the way up to create a contact sheet or character sheet for a lion, which is quite useful, especially when it comes to creative iterations, and you can really combine these workflows together to create interesting processes. So when it comes to actually how we connect this to Nuke, you can then compound the whole element, the whole workflow into one gizmo at the moment, and that gizmo can be running inside of Nuke. So your prompt will be happening inside of Nuke, and the image will come back to Nuke. In this case, I'm using Nano Banana from Google. That can generate an image, so I'm transforming that particular picture to day and night. If you're expecting lots of revisions on that particular picture, just like with any AI models, that is really stop this at this moment. It will turn it to day to night, but you have really minimal control over what windows will be light up and so on. If there are creative revisions, you can start generating multiple pictures and then start compositing it all together and essentially start doing the regular 2D workflow to generate exactly what you need. This workflow is also already updated to allow you to compress all of this work into a Nuke nodes library, so I can then publish a specific workflow all the way up to the generation of the item that I'm trying to do. I'm checking or telling Griptape to export this to a specific Nuke install library, and when I publish this, then I can simply go to Nuke, open up the Griptape entry here, and then bring in the particular compressed workflow into one node that will do exactly the same that we'll do inside of Griptape. So you can create the workflows and really generate your own AI-driven tools that can be then ingested and consumed by Nuke and generate those images directly inside of the application. So now it's connecting, I'm just telling it where to save the image, and when I run this from inside of Nuke, it will call Nuke Griptape engine. Griptape engine will call the AI model. AI model will create a picture will come back, and then I have a teddy bear element at the end, or the background. Okay, so I think one of the use case scenarios for these AI models these days is, for example, creative exploration, right? Like there is a lot of work that is usually going to revisions and iterations and figuring out what we are really actually doing. Rather than focusing on the final pixel, which none of these models are really capable of doing these days, you can really explore and deliver and communicate your intent much better by exploring various visual iterations of any given shot. So I'm feeding a video here into the model, and then I'm feeding a look that I would like to achieve. In this case, it's this kind of image right here. And by building the workflow, I can then keep on swapping the image to create look that might look like this, like this, like this, like this, and so on. And all of this can be communicated to the director, to anybody who will actually commission you to develop it fully. This doesn't make final pixel by any means. It's a good creative exploration, but at this point in time, the models are fairly limited.
Hello, my name is Victor. I'm, for those of you that do not know me for now, I am the representative, the India manager for Volinga. Volinga is a software company that basically helps creating Gaussian Splats, etc. Today, what I wanted to speak about is basically this problem that every production is nowadays having. Basically, the issue of time, realism, and budget. at the end, if you want to reduce the time that it takes you to do something, either you cut on how realistic things are, or you increase your budget. If you want to make things more realistic, either you spend more time or you spend more resources on it. And if you want to reduce your budget, either you cut your time or you make it less realistic. And this is what Volinga helps you do, basically by deploying 3DGS in virtual productions. Some of you might wonder, or I don't know how many of you are comfortable with 3D Gaussian splatting, with the technology, but basically it is a capture technology that allows you to create 3D environments using videos and pictures. You basically add those videos, pictures, regardless of how they've been created, and it transforms it into a photorealistic environment without manual work. And that is the main point, that it reduces incredibly the amount of labor that you will need to spend. And basically the way that this technology works is with this thing called splats. Splats are basically, if you go back to your math classes from high school, this Gaussian curve, you basically store it in the picture at various points. So the system remembers basically the position of that splat, the covariance, basically the shape of it, the opacity, and the color and the reflection based on one thing called spherical harmonics. And this allows and creates, between this million of tiny splats, it creates the entire image. The way that it's starting to be used more and more is, of course, because it works in real time. The way that you can render it, it's interactive and at extremely fast rates. It's much faster than previous technologies. And of course, people are now using it because, well, it drastically reduces the cost and times. You can basically either spend less time doing your 3D environment, or you can spend the same amount of time and make things of a higher quality. So that is why more and more programs like Nuke, for example, are incorporating it into their software. But it's not only software programs. Of course, big productions are using it as well. You might have seen it in movies such as like Jurassic World or the new Superman movie. All of them are using it. So now when it comes to the stack itself and how it works, basically you have 3 steps. You, of course, create it, then you have to edit it, and then you render it. For the creation of the splat, you basically have a few different modes. You could do it with videos, with pictures, anything from 100 pictures to however, the sky's the limit, the more the better, of course. Cameras is independent of the camera, of course. The better the quality of the camera, the better the outcome will be, but you can do amazing things with an iPhone phone, for example. You can also use LiDAR. Some of you might be comfortable with the technology. Basically, it creates a dot cloud that is very accurate in terms of positioning. Not so much, of course, then of colorings, but there are ways to implement both camera and LiDAR to combine them both and create a very accurate 3D environment. And you can also do it with generative AI, kind of like as was mentioned before, using things like Nano Banana. You can create an image, do a rough draft, and then input it into something like our Volinga suite, which creates out of all these images the splat, basically. All these splats. I will show you a video of how this editing or creation might happen, but allow me So basically, you drag and drop the different pictures or videos that you might have. You can configure, fine-tune, of course, the different settings, the amount of iterations that you're going to have, the checkpoints. You can queue up all the different images, and it will create the splat. In terms of the time that it takes, it's a little bit variable. It depends, of course, on the number of images that you might have. It depends on the quality of those images. But let's say something from 20 minutes to 2 hours in total. So we're speaking about having a very good environment like this. You can create a scene in no time that is extremely photorealistic. It of course supports ACES, HDR, etc. for color grading, color correcting. And we'll go on to how you can edit them. Because of course you're going to need to edit some splats if you so desire. Let's say that's something that you had a fly inside of the picture that you were taking. So of course you can. You have to be able to edit them. The software that we have, Volinga Suite, is able to move the splats, to clean them. You can duplicate them. You have all the tools that any professional artist may need. So we have all the tools that you might be familiarized with, kind of like Lasso or any others, to basically be able to edit the splats and edit your 3D environment. At the end, it's something that we've made for professional virtual production. So all the tools that you might need are there. And lastly, you of course need to be able to render them, and renderization is extremely quick as well. We have a plugin for Unreal Engine. The plugin is from version 5.2 onwards, so hopefully 5.8 as well will be soon. And of course it allows for all the post-process effects that you might need, color correction, depth of field, relighting. I think images speak for themselves. I think I will allow you to see the video, because you can see all the reflections and all the qualities that basically are added with Gaussian Splats. So here you can see the movement of the light. You can see the reflections there in the water. Of course, again, color grading. And well, lastly, I will try, although I'm not sure if it will work, because the reason why I'm not showing the presentation that I had was because it was crashing. I will try to show you some examples, real use examples. So basically we had this series that was using they were trying to film on top of a silo. It comes into problems because, of course, you need to build scaffolding around it to be able to film. It takes time. It makes it complicated logistically, safety-wise for the actors, etc. And at the end, the episode needs to come out next week. So we helped them build a 3D splat. Here's the silo. And they were able to build it with drone footage and then record it on a volume afterwards. So you will see here, this is the 3D environment, how you can move easily across it, and the amount of detail that it has, and how quickly you can make something like this. That is the truly amazing feature of this technology, of course. And now this is how it came out. So of course there are parts that are external. This part is in the VP stage. And you can create extremely good and extremely realistic environments with this technology. Okay, lastly, I will show one last example that is basically from Auschwitz. Auschwitz, as you might know, it's still preserved. But you cannot film inside usually. It's very limited. So, for example, if you think of this typical movie, the Schindler's List, they had to build a replica in order to be able to record. So you could not actually record there. So one thing that the Auschwitz Foundation has done is they wanted to preserve the site and to allow people to record inside, quote unquote, without recording inside. So they made this 3D representation of it, and now also one more detail about this is, of course, that you can, because there are visitors, it is only open, or it is only available to be recorded on 2 days of the year, which is the 25th of December and the 1st of January. So at the end, what was able to be done is to use pictures and videos of it to make a full recording and to be able to create this 3D environment of Auschwitz. And well, with this video, we will end the presentation. If any of you have any questions, please feel free to raise your hand or to ask me afterwards. I'll be around, so thank you very much.